All right, here we go. Today we're going to take a look at an extension of the law of signs, and it's called the ambiguous case. In your geometry classes, you would have learned that if you had an angle-angle side pattern, angle-angle side or angle-side angle pattern, that you were guaranteed to have a triangle. You also learned that if you had side angle side or side side side, you were also able to use that to prove some triangles congruent. But what your geometry teachers would have mentioned is that side side angle, or sometimes if they wrote it the other way around, it definitely spelled something that you weren't allowed to write on your paper, that was not a triangle congruence pattern. This is called the ambiguous case. So when we have a side side angle pattern, so for example in my picture, what I could say is that let's pretend I knew the measure of that side, I'll put a tick mark on it, and I know the measure of this side, I'll just put two tick marks on it, and I know the measure of this angle. This would be a side-side angle pattern. I've got two sides and I have a non-included angle. Now, whenever you have this scenario, there are three potential things that could happen. It's possible that the values you're given don't create a triangle at all. And what you can see down here is I've given you some pictures drawn to scale so you can kind of understand why you could have a scenario with no triangle. So you can see I've got two side measurements and I have a non-included angle. These pictures have been actually constructed to scale, so you can see that based on these measurements, this side is never actually going to reach that other side, and there's no way for me to extend it or rotate it in a way to reach. It's also possible that the dimensions that I give only create a single triangle. That would be this scenario right here. Again, I have two sides and I have a non-included angle, and this is the only triangle that I'm going to be able to draw from this. Now, to understand why I can't get a second triangle from this, but sometimes I can get one, is best to look over here. Again, I have two sides and I have a non-included angle. And what's going to happen is if I take this side right here, in particular, the side that's across from the given angle, if I imagine this side swinging in and creating a little isosceles triangle, then I would know that this little piece right here would be the same as that 9. Thus, I create a second triangle that would look like this little piece of the wiki stick, this small little piece here, and the original 13. So I could have this triangle, or I could have this triangle, the original, and create two triangles. Understanding that swing idea, we could come back here, and if I tried to move this side that's across from this given angle, and I tried to move it, there's no way that I can move it and create a different triangle than what I originally started with. So these are the three scenarios that you need to consider, but these scenarios only need to be considered when it's a side-side angle pattern. None of our other patterns would ever require any of this analysis. So when we're trying to figure out how could our second triangle potentially look, that's what we're going to study on this page of notes. So on this page of notes, all we're going to look at is how to get a visual of what that potential second triangle might look like, understanding that the first triangle might not even exist itself. So the first thing that I like to do, actually I'm going to come back up here and look one more time. In this scenario, what I always tell students to look for first is what we call the hinge and how we're going to move something. Your hinge, think of a door hinge, will always be between the two given sides, and the side that will potentially move in is always going to be the side across from the given angle. Now, in this case, what would happen is this would be my little hinge, and the side that's going to move, this could swing inside. The reason, if you spend some time playing with it, that makes sense is because if I tried to move anything else, it would change my other given side or my given angle. But by taking the side across from the given angle, moving it inside the triangle, I maintain the length of that side I maintain the length of the other given side, and I maintain the original given angle. If I try to move anything else, for example, if I tried to move it this way, let's say I tried to make this my hinge. If I try to move that in, I'm now changing the length of this side, so it won't work. If I try to move either of these sides, it's going to change not only this side, but it's going to change the other given angle. So remember, the hinge has to be between the two given sides. So let's take a look down below so that we can kind of practice working on some things without having to draw some things to scale. So looking at our 6 pictures here, the first thing that we want to answer is, where's the hinge? It's always going to be between the given sides. Sorry about that. Oops. Okay, between the given sides. So what I tell students to do is put a dot on it. So find the angle that's between the two given sides. So that has to be my hinge each time. Now, which side should actually do the moving? This is going to be across from the given angle. So you'll only know one angle measure. So if this is my given angle, this side has to move. If this is my given angle, this side has to move. 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 If you need, pause the video and just kind of think through those 2 steps because those are crucial elements in order to draw the second triangle. Okay, now sketching the possible second triangle. Remember, the second triangle might not exist. In fact, the first triangle might not exist. So what I'm going to do is I'm going to use a little wiki stick, and certainly in class you could do that. If you're home, grab a piece of spaghetti. That works just as well. So I like to put my finger on where the hinge is because that helps me keep in mind what's supposed to move, and I visualize this moving inside. So when I redraw my picture, I know that I need to keep this original 15. I know that I need to keep this 22 degrees. So I'm just going to redraw this and I'm going to let it go really long. That's okay. And then when I draw the wiki stick, I just draw it straight down. This is not to scale and that's perfectly fine. And I know that it's created an isosceles triangle, so I put a 10 on it. This would be my potential second triangle drawn horribly, horribly not to scale, which is perfectly fine. So let's try another one. I'm going to put my wiki stick on the side that's supposed to move. I'm going to put my finger on the part that's supposed to be the hinge so I don't accidentally move in the wrong way. And I'm going to move this to the inside here. So when I redraw this, I know I need to maintain the 10. I need to maintain the 65, so I'm going to extend that long. And then I just drop the wiki stick straight down, knowing that it's supposed to be this 15. Okay? So let's keep going. If you want, you can pause the video and give the next one a try, see if you get that one right, and I'll go ahead and write that out. Okay, I've put my wiki stick on there. I'm going to move it to the inside. I'm going to maintain my 15. I'm going to maintain my 93. I'm going to drop the wiki stick in, and I know it's supposed to be 27. Keep going. Again, if you want to pause the video and give these a try, you can certainly do that. So if you want to keep watching, I'll keep talking through. Hinge, press, move in. I'm going to maintain the 27. I'm going to maintain the 22 degrees. And then I'm going to draw in the little line for the wiki stick. Keep going. I'm going to move that to the inside. keep the 27, keep the 65. Drop in the wiki stick. Last one. Press down where the hinge is, move it to the inside. Going to keep my 10, I'm going to keep my 93, and I'm going to drop in the wiki stick. And that's what we have. So on the remaining pages, we're going to look into some examples, but it is very crucial that you understand this element first. Please, if you have any questions, any parts of this process that you are struggling with, jot those questions down right now on a sticky note or on the side of your notes, and we'll answer those before we start examples in class.